afternoon, gentlemen. Good afternoon, Mr. General. Pens down now, screens down, 45-degree angle. Thank you. Pens down. Awesome. We are learning about multiples and factors, so we'll focus on multiples for this lesson, and then we'll talk about factors and what's the difference between them. So multiples, if you buy something in groups of 3, for example, let's say you bought a particular chocolate, but in one pack there's only 3 chocolates. There's no less than 3, no more than 3. So if you bought 2 packets, how many chocolates would you have?
6.
If you had 3 packets, how many chocolates would you have? If you had 4 packets? 12. In other words, if I'm a mathematician, I would say I'm buying these chocolates in multiples of 3. Does that make sense? Because you have packets of 3. So what are multiples? Multiples are the numbers that result from multiplying a number by another whole number. So let's talk about 3. So what's the first multiple of 3? What if you only had 1 packet? 3. So if you had 2 packets, you're timesing 3 by 2. How many do you have? 6. So what would be the next multiple? 9. Next one? 12. Awesome. So multiples are those numbers that come in the times table. 3 times 1 is 3. So that's the first useful multiple of 3. 3 times 2 is 6. 3 times 3 is 9. And 3 times 4 is 12. 3 times 5 is 15. Do we understand what multiples are? Yes. So remember chocolates, packets. Okay? Now, how many multiples would 3 have? Raise hands.
Wait. Infinite?
Infinite. Because does it actually end? If I multiply 3 by 100, I get 300. Then I can find the next one. 3 times 101. Do the numbers ever end? No. So how many multiples will a number have? Infinite. So will I ever ask you to write all possible multiples of a number? No. So we'll always actually tell you write the first 5 multiples or 10 multiples or a limited number. So remember, M for multiples, M for many. That means there are way too many to write on a sheet of paper. So we always asked a limited amount of multiples. Make sense? Alright, can you just calm down, stop? That can wait. Okay, let's write the first 5 multiples of 3. So what's 3 times 1? 3 times 1? 3. 3 times 2? 6. 3 times 3? 9. So yep, you can either do that, or you can just write the first multiple of 3 is 3 itself, then 6, 9, 12, 1, 2, 3, 4, 5. No, I asked you for first 5. Is that it?
Yes.
Awesome. So when I ask you for first 5, you have to start from the number itself. If I ask you for any 5, you can start from wherever. But if I ask you for the first 5 multiples, you must start from the number itself. In primary school, you were asked, count in 3s. That's what it meant. Basically, just the multiples of 3. Make sense?
Yeah.
Now, first 5 multiples of 5. Can I start from anywhere? Any multiple of 5? No. Did I ask you to give me any random multiples? No. I asked for first 5 multiples. Can you stop doing that, please? Turn it off, your laptop. Thank you. So, we start from the number itself. 5 times 1 is 5. 5 times 2 is
10.
5 times 3 is
15.
5 times 4?
20.
5 times 5?
25.
Do we have the first 5 multiples?
Yes.
That's it, done. Now, something called the lowest common multiple. Another way of asking that is LCM. So first I'll tell you how to find the LCM of 2 numbers, and then I'll give you an example. Why did I teach you, where in life would you actually need it? Okay? So let's first find out how to find the lowest common multiple. So first find the multiples of 3. Again, is it possible to write all the multiples of 3? No. So I'm going to write a few until I think that I have a multiple of 4 as well. So 3 times 1? 3 times 2?
6.
3 times 3?
9.
3 times 4?
12.
3 times 5?
15.
And so on. Right? Then you write the multiples of the second number, which is
4.
4. 4 times 1? 4 times 1? 4 times 2?
8.
4 times 3?
12.
4 times 4?
16.
Now, the lowest common multiple. Are these multiples? Yes. So we've written multiples. Common means same. The lowest means the lowest possible multiple that belongs to both 3 and 4. So let's have a look. Which is the multiple that belongs to both of them?
4.
Do we all agree with that?
Yes.
That is the LCM of 3 and 4. The first multiple that they both have in common. Do we know how to find LCM now?
Yes.
So you'll write your answer. So this is your working out. You must show this working out. And then you'll write LCM of 3 and 4 is 12. Now, can anyone think of a real life example where you use it? No? Okay, I'm going to use an example. So let's say I started going to the gym, which doesn't really happen, I should. Let's just say I did. And let's say my sister then said, okay, I'm going to start as well. So we started, but we started at the same time, joined the membership. I go every 3rd day of the month, so every 3rd day I'll go. She goes every 4th day. What's the first day in that time period that we'll both be there together in the gym? How did you figure it out? So let's think of it in terms of multiples. Well done. So if I'm going every 3rd day, I'll be there on the 3rd day, 6th day, 9th day, 12th day, 15th day, so on. So my sister will be there on the 4th day, 8th day, and 12th day. So isn't the LCM actually the first day when we'll both be there together?
Yes.
So these are the kinds of examples where you get to use the lowest common multiple. When we're doing things in groups of something, like buying chocolates in groups of 3, like going to the gym, or running, if I'm running a circuit and I'm doing a lap every 5 minutes, my sister's doing a lap every 4 minutes. When will we both finish a lap together? 20, because isn't 20 the first multiple of 4 and 5?
Yeah.
Is it making sense now where we'll use multiples?
Yes.
Perfect.
Isn't it just easier to multiply in the running around the ocean case 4 times 5?
That's not always the case. So for example, yes, in that case it works, but not for all numbers. The lowest common multiple is not necessarily that numbers times that. So for example, what's the first common multiple of 5 and 10? 10. But it's not equal to 5 times 10. Does that make sense? So a very good question. You might have noticed that the first common multiple of 3 and 4 is 3 times 4. That works in this case, but that's not true for every 2 numbers. Like, let's find the LCM of 5 and 10. So, what are the multiples of 5?
10, 15,
Multiples of 10?
10, 20, 30.
What's the first common multiple?
10.
Is it equal to 5 times 10?
No.
So LCM is not necessarily timesing the numbers together. Make sense? Any other questions? Awesome, get on with your work.